Of all the valuable data we discuss on the AI forecast, it is hard to contest that any of it compares to the value of medical data. If we access it properly with predictive analytics and AI, healthcare data has the potential to not only improve, but save lives. But turning complex siloed medical data into accessible, actionable insight is a massive technical challenge. Hi, I'm Paul Muller, the host of the AI Forecast, a weekly podcast sponsored by Cloudera that explores the past, the present, the future of enterprise AI with leading companies and industry experts. Today, we sit down with Luz Erez to talk about how his company, MDClone, is capable of managing records of up to 20 million patients per site. These sorts of records include genetic data, electronic healthcare records, medical information, test results, insights into hospital admissions, and emergency service usages. Welcome to the podcast, Luz.
Thank you very much. Happy to be here.
So let's just get started. First question. We do a little bit of a lightning round.
Okay.
4 questions.
Okay.
Yeah? Bit of fun.
Yeah.
First
sure.
question.
Yeah.
I don't know how this translates to Hebrew, so I'll do it in English.
Okay. You can do it in Hebrew. I think.
I wish I could. I wish I could. What would people who know you best say is your superpower?
I have an answer to every question. Most of them are not correct. That's me. That's me.
Is that your wife's opinion?
Yeah, my wife for sure. She said never correct, but most people say, it's amazing. I always can get an answer from you, but I say, yes, that's correct. But most of them are just I invent and as I go on. That's okay.
I'm sure.
Okay.
So is there another superpower?
My background is for physics. And I'm working in the area of computers, but people. And in many cases, in most cases, I'm trying to do, as you do in physics, to find the basic rules that create things. So what a physicist do is always trying to find the basic laws that drive things. And if you really understand them, and in many cases it's possible to do, then you can drive a lot of insights from those basic rules. And many systems looks very complex, but when you get to the bottom of them, understanding that there is a basic rule that govern all of those, it's one of the most important things. So this is my really best thing I really excel when I see complex system and then I don't do anything and I just find the basic rules that govern the things. And from this point on, I'm looking like this very smart person, but actually I just see how those basic rules apply for each one of those situations.
We have to do a podcast then at some stage about unifying quantum mechanics and relativity.
I totally willing to do so.
That'll be so much fun. All right.
Yeah.
I was just reading Carlo Rovelli's book, if you know Helgoland,
sure,
which is great.
sure.
So all about that right now. All right, next question.
Okay.
What do you think is the most impactful technology of all time?
Generative AI, by no question about it. I have no question about it. Generative AI, we are just seeing the tip of the iceberg. And I'm a very old person. I'm a boomer, so I've seen a lot of technologies starting from early computing. There is nothing even close to what generative will offer to us, and it is unproportional to anything we've seen before. I'm totally sure with this, and I can give an infinite number of examples that it will totally alter our lives.
We talk about AI. We just talked about AI. We talk about what it's going to do for business. We're going to talk about what it does in the medical industry.
Yeah.
But what would you like to see AI automate for you personally?
Personally, I don't have a lot of requirements because sitting at the beach and doing scuba diving, I don't need AI for this. And this is my desire in life. But I think that I really trying to take it into small bits. And just an example of when I was a kid, when I went to the primary caregiver, he spoke with me. Today, when you are going to a primary caregiver, he can't even check you because he's on the computer all the time. So one of the things that happened to us during the last 40 years, we lost contact with people. And I really believe that this is an example that I see in front of my life, real life, that we are taking this back. This means instead of a physician doing 60%, this is a real number, of his time behind the desk, doing all kind of registering things, regulation, dosing, and so on. He will be with you as a person, and the rest of the unimportant work, it is important, but it is something that generative AI and AI can do for us, will be done by it, and it will totally alter the way that we interact. And I think that many of the things that we really wished when we are looking at the past, saying, I really say, it was wonderful those days, many of those things will return. Free time will be more, and a lot of the interactions that we don't like about work, things that we're doing repeatedly, and so on, will be done by machines. And then I really believe it's much, much better future. I really believe.
I'm excited. That sounds cool. Last question for you from the first four. You work with data all the time.
Yeah.
What's a tip or a trick or some best practices you've learned as someone who works with data all the time?
Okay, so I have a great one. It is not only good for data, it is good for many other things.
Tell me.
I'm doing a lot of off-roading, and so if you're from Australia, and when you look at the procedure, when you see somewhere a vehicle that is going to the side, or it is. So first thing, procedures. By the way, this is even in military doctrine. First thing you do, you see something like this, you check that everyone is okay, and then you drink coffee. This is the most important thing, because many times, and I see it all the time with our clients and so on, they want to have a procedure what they should do. First thing, think. If everything else fails, read once the instruction. But everything else has to be failed before you read the instructions.
In the Air Force, they say wind the clock.
Exactly. So one of the most important thing is not everything is the same. If you'll just pause, like for X minutes, and say, what are my options? Put in them. Because we have this tendency, doing this, the last thing that worked for us, again, let's try this again. This was the best thing anything, like any equipment, you just bought the equipment. This equipment will fix this. Stop, drink coffee, wait a bit, and then this is for data science. This is so important because so many times I see people that work for 3 weeks on some kind of a correlation type and they are doing it again and again and again. I say, stop, move. And they what to do? I say, move away from the computer, shut it down. Now let's think what we are doing. What is our goal? And especially for data scientists are people that are orderly. They have order for something. You'll do this and you correlation, they do p-value and so on and so on. Most of the time, so many people do this without thinking, and they get totally hilarious results because they didn't done the most basic thinking before they started to think about. And this is a very good. If you'll ask me, you can ask me about so many things. I will give you the same answer.
I think it's a great answer. One of the best answers ever on the show, I think. I'm going to take that. That's a life lesson.
Yeah. That's a life lesson.
Free counseling.
Yeah, free counseling. Sure. I'm ready to do this.
Tell us a bit about you, because it sounds like you've had an interesting background, and we'll talk obviously about what you're doing at MDClone.
So for my background, it comes from physics, and physics is an amazing science because in physics, when you want to test something, you move the laser a bit. You press the button and you have a test. Then you move it back and you have another test. Then my life showed that working in physics is not the most profitable things. And I have a family and so on. And my wife looked at this and say, are you doing something with your life or just playing? And then this is our second company that we are as a group. We are a group of people that work in healthcare. So we are working for some years in healthcare. So some of people in our company started interoperability. And now we went into research and we saw that in research, there is no tool for retrospective research. And retrospective research is a very complex thing. So retrospective...
What does it mean?
Okay, this means that I'm doing research not by trial that I create, by looking at data of patients that already exist. So this is retrospective. And most of the time, and many people understand, there is a difference between correlation and causality. So we tell it all the time. And And every time you read a paper saying people that drink coffee such and such, and so on, all of it comes for correlation and not from causality. And one of the things that as I started to look at this, I understood there are multiple problems here. First of all, there is a very complex problem about how do you understand medical data. For instance, a question in medical data is, I want to get all the medication of patients that has a relapse in their kidney disease while they are on a beta blocker. This type of question, the tools that existed in the world, like SQL and so on, does not answer.
Why?
So it's complex because what is to be on a beta blocker? What is a relapse? You have to define it before you answer this. And so one of the things that, as I explained before, as a physicist, I say, okay, what are the basic rules? And the basic rules are rules of time and people. This means this is longitudinal. So the main question is, how frequent is something? What is deterioration? Is something that happen bad more frequent? Mm-hmm. It's as simple as this, but how do I quantify this? How do I put rules in it? Once I put the mathematics inside of it, I could really build on top of it some kind of logic and a system. And the next thing I saw that, okay, I can give the answers, but I cannot give anyone the answer. And this was another question. Why? Because a physician can ask any question about his patient. But if you want to ask a retrospective about a population, you need consent. You have the problem of privacy. So how do you solve this? And for this, I created I've seen what exists in the world, and there's things like anonymization and epsilon differential privacy and so on. Then I thought there is another solution if you want to be on scale. And the solution for this, we've built something called synthetic data. What is synthetic data? The engine looks at the data, and you just write a query, but it does not give you the data. It gives you a list of avatars that looks like the original data. Any statistics will be the same, but you can train models on them and so on, but there is not one-to-one correlation between one-to-one. So this is another set of people that have the same data as the one that you've asked on. And then there is no PHI issue with it, and then you can send it to a pharma company, you can share it with your mates, and so on and so on. So the fact that I solved the first problem did not allow me to solve the second, but I have to solve both of them.
At the same time.
And synthetic data today has a major role in AI, and this is like something new to us, okay? Yeah. Because if you look at it, you ask Gemini, for instance, you have a medical condition, and you want to know for this medical condition, what are your options? If you ask Gemini, it will tell you nothing. It will tell you something from your textbook, because it does not know what your options are. Because you will live in Australia, so it has to look at what are the clinics near you, what they are offering, and what is your insurance, and so on and so on. What is your insurance? So today what happens is that all the generative AI finished learning all the open information in the world. Mm-hmm. But if we want to give them to be smarter, we need something else. We need them to have access to concealed information, like private information. So if they will see medical files, they can give you. It's not a problem of the mechanism itself. Gemini or OpenAI does not have access to the data that is relevant for you in Sydney in clinics. And in order to do so, synthetic data solves this.
So the question, though, is in order to get the synthetic data of a sufficient fidelity of quality, surely it has to itself come from actual data.
Yeah, sure. It looks at actual data and create, and then there is a balance between privacy, so you set the level of privacy, and then we give you as best utility as possible. And this is very complex. I tell it because I want to sell the system, and if you think it's simple, you'll write it by yourself.
No, but genuinely, so you still have a lot of the same data handling, ethics and privacy concerns in the preparation phase.
No.
But that, okay. Tell me
no,
why.
because the engine do it automatically. Because the problem there is a problem because people see it, and maybe in the data, there is a data of your aunt, and say, wow, why is my aunt there? She shouldn't be in something like this. But if a machine does this, and you see only synthetic data, then this whole governance and so on, let's go away. All those problems go away. This is a magic bullet that solves all the issue, if it can solve it. Not everything can be synthetic data. For outliers, rare cases, it's very hard to build because there's not enough statistics. But for common, regular medical data, we can supply synthetic data that will be the same from any analysis. The only thing you wouldn't be able to take any specific information about a specific person, and all our clients, we have like Chicago University, we have here Manchester, all the users that use our data gave permission to the users to use it without IRB or without Helsinki. So you don't need Helsinki when you use MDClone. So you just go to the system and you don't have to commit it to a committee and so on, because the system behind the background do all this work for you.
So how do you see this changing the future of medicine in terms of how it's practiced, whether it's at the research level or at the GP level?
Okay, so first of all, there is the research. So it's much easier to do research, medical research. This is one thing, but again, as we go to AI and think about AI agents. So now everything's AI agent, and we are working just with the companies that are doing dosing. This is a very small thing. So how do you do? If you're a primary caregiver, there is something like 1.5 minutes out of every session. When you give a medication, you will say, what is the exact medication and so on. And this can be done amazingly by agents, unbelievably. 99.99% accuracy. This is not good enough. For something that do dosing, you need 99.999999. You are not willing to, your kid come and say, oh, he was the 1,000 kids that we missed.
Understood,
you can.
Yeah.
So how do you make sure that it is not doing hallucination? And in order to do so, what you need is to test it a lot of time. How do you test it? You need a lot of data, hundreds of thousands of cases. You don't have hundreds of thousands of cases. With synthetic data, I can do something called bootstrapping and make sure that an agent like this works 100% of the time. I will create more cases and more cases and more cases until, and we are working on a project, and we show that a physician, primary caregiver, can save up to 40 or 60% of the time of a session by agent like this. The problem, you need to validate them that they are working correctly. So if this agent is doing referencing on your data or doing dosing or doing something else, you need to be 100%. And I really believe that synthetic data is one of the bedrock of this technology, because without it, just looking at protocols and so on, you cannot.
It sounds like it's going to change medicine. It's incredible.
Yeah, it's amazing.
If people are interested in learning more about this, where can they go?
So we have a website, mdclone.com. On it is a lot of material. Or freely connect me through LinkedIn, and I will be more than happy. Privacy is my baby, so I have a session about privacy that start with the session. If you know the Bible, start with Adam and Eve. Yes. And they eat from the fruit. And the first thing they are doing, they are covering themselves. So they are becoming smart. And the first thing they think about is they have a privacy issue. I have a privacy issue. First thing, not how to be rich, not how to work better, not how to get better food. First thing they say, they are more smart now. We have a privacy issue.
That may be the first biblical reference on this show, I have.
Yeah. So this is the basic thing about Genesis. Is we have a privacy issue. If we'll solve this, other thing will be easy to solve.
Excellent. All right, Toda Rabat, thank you so much for joining us.
Thank you for asking me.
If you like what you've heard, please do make sure to like, share, and subscribe. If you've got any comments, you can always hit us up in the comments section, either in the app or on LinkedIn using the handle @Cloudera. With that, we'll see you all next week.